Okay, welcome. In this video, we are going to go over how to use your factoring flowchart. In my years of teaching, I have noticed that students, after they learn how to factor all the different ways, they're not sure when to use which one. So this is going to help us with that. And so I'm just going to show you how to use this. And every time you factor, I want you to have this out to help you. It's also helpful to have out your multiplication chart. And then as we go through this, we're going to work on this practice mixed factoring, so you have something to apply it to. This video is not meant to be a deep practice or instruction on each one of them, although I'll show you a quick example. So if you need help on any of them that you're not feeling that confident in, just please come see me so I can help you learn how to do each of these. This is more about when do I do each of these, and then just a quick review of each of them are. All right, so for every single problem, that's why this is in flowchart form, is because I want you to start here. You need to factor any GCF out. Always, always, always. Sometimes there might not be a GCF, but if there is one, you need to factor it out first in order to get fully factored. So I want you to get in the habit of looking for that. All right, so first look for any GCF and then factor it out. So to factor this out, here's our example. We're looking for a number that divides into 3 and 12 evenly. That would be our factor, so that number is 3. And then x squared and x, well, we just need to factor, the greatest common factor would be that variable, but the lowest exponent of those two variables. So x, when we don't see anything there, that's to the power of 1. Okay, so that means that our GCF for the number is 3 and that our GCF for the variables is x. When we are factoring, what we are doing is dividing. So now you're going to take each of these terms, so 3x squared and negative 12x to the power of 1, and you're going to divide by 3x. So 3 divided by 3 is 1. We don't need to put anything there. And x squared divided by x, well, I just subtract the exponent. Since this exponent is 2, and since this exponent, when there's nothing there, is 1, we subtract this, and we have x to the power of 1. Again, I'm just not writing anything there. And then I'm going to take negative 12x, and I'm going to divide by 3x. So just to see this off to the side here, negative 12x divided by 3x. Well, negative 12 divided by 3 is going to give me a negative 4. And when I subtract these exponents, I get a exponent of 0, which means that this is now 1, or we can think of it as just canceling out. So that's where this negative 4 comes from. You should also get in the habit of checking your trinomials, and that greatest common factor has to be in all of the terms. So for instance, we have an x squared and an x, but since there's not an x there, we're not going to factor out an x. But a 2 is a factor of all three of these numbers, so we divide each term by 2. So 2x squared divided by 2 is x squared. Negative 10x divided by 2 is negative 5x. And 12 divided by 2 is 6. Okay, I also want to add this in here because this screws my kids up every time. But if there's a negative on that leading term, they get confused on what to do with that, especially later on in the factoring. So just get in the habit of, if there's a negative up there, just factor out that negative. Okay, so instead of factoring by a 3, I'm going to factor by a negative 3. How that changes is first I got this is now negative 3x. And when I divide by a negative. That means that the signs are going to change. So now this is just positive x, and then this next part is negative 4. Same thing with a trinomial. If we have a negative 2 out front, or even if we just have a negative and there's it's just a negative 1, go ahead and factor out that negative at the beginning. It's going to help you out. So here I would do, it just changes all the signs. So I'm going to factor out a negative 2. So now this is positive x squared. This is negative 5x. And a negative 12 divided by a negative 2 is a positive 6. Make sure you get this in your notes. This is also important, even though it wasn't actually printed on here. Okay, so let's see what happens with these problems down here. Let's go ahead and see which one of these we would have to do that for. So pause the video and take a look at every one of these problems and determine if there's a GCF. And I want you to write GCF next to the problem, so that way when we come back to them later to factor them, we know that we have to start with that. Eventually you just need to do that every single time, but let's see if we can recognize when there has to be a GCF factored out. So go ahead and pause and see if you can find them and write GCF next to that problem. Okay, here are the ones that I found. Number 1, we can factor out an x. From number 2, we can factor out a 4 and also an m. Now, some people might have chosen number 4, so let's look at that really quick. Can I factor anything out of number 4, greatest common factor? Well, I see that there's a 4 here and an x squared, and a 4 here and an x, but neither of those things are here. And in order to factor out our GCF, it has to be true for all 3 things. So make sure that you're only factoring out a GCF when it's true for when the GCF is found in all 3 terms. And then looking at number 7, the GCF looks like I could factor out a 3. So when I go to do these problems, I want to make sure that I go ahead and start by factoring out that GCF. And I would just want you to get in the habit of doing that every time, so that way we have fully factored polynomials. Okay, so next on our flowchart, after we first looked for any GCF, we're going to determine if it's a 2-term polynomial, a 3-term polynomial, or a 4-term polynomial. So let's take a look first at our 2-term polynomials. So once we've factored out the GCF, we need to look to see if it's a difference of squares. Okay, so what's a perfect square? Well, perfect square is just a number that you get when you have a number and you multiply it by itself or you square it. So for instance, this multiplication chart highlights all the perfect squares. So 2 times 2 is 4. 4 is your perfect square. 3 times 3 is 9. 9 is your perfect square. 4 times 4 is 16, and so on. So all of these right here are our first 15 perfect squares. They could also be written as 2 times 2 is 4, right? But I can write 2 times 2 is 2 squared. And that's important because you also want to think about, well, when are variables perfect squares? Well, x times x is x squared. So when I see x squared, that is a perfect square as well. 4 is a perfect square and x squared is a perfect square. Okay, so we're going to look and see if we have perfect squares. So let's look at our numbers and then we can see the rule here. So if we have squares, this is how we're going to factor it. That's our rule. Here's our example. Do we have perfect squares? Well, 4, check, that is a perfect square. You can look at your chart. 25, that is a perfect square. You can look at your chart. And then x squared is also a perfect square. So yes, both terms are perfect squares. And then the next thing we have to look for is that it's a difference, meaning they're being subtracted. Well, yes, they are being subtracted. So I've now confirmed that I have a difference of squares. Now that I know that it's a difference of squares, I know that this is the way that I need to factor it. And the way to do that is you're just going to take the square root of each of the terms and plop it in the parentheses. So what's going on here is we're taking the square root of 4x squared and we are getting 2x. Because the square root of 4 is 2 and the square root of x squared is x. And then we're going to take the square root of this term. Don't worry about that sign. We're just going to take that integer. And the square root of 25 is 5. Okay, and then the final step is we just need to make sure that we put in a positive and a negative. It doesn't matter in what order, but that's how you factor these. Okay, well, what about sum of squares? Okay, so here, again, we want to see that we have perfect squares and that this time they're a sum. However, if you see that, then you're done. You don't need a factor anymore because they do not factor. Okay, and then we have sum and difference of cubes. And I'll tell you what, we're actually not going to go into this in this video. It's good to have it on this flow chart here, but it doesn't occur that often. And when it does, we will just refer back to this and work on them together in class. So what that means for you is once you've factored out that GCF of a binomial of 2 terms, it's always good to have the vocab word there. If you've determined it's a difference of squares, then you're going to factor it. If you have determined that it is a sum of squares, then you're not going to do anything to it. So really, we're just looking for this difference of squares here in this class. This is the important thing. If it's not a difference of squares, then you're done. There's no more factoring to be done. Okay, so let's say I've started a new problem. The first thing I'm going to do is look to see if there's any GCFs that I need to factor out. And then I've determined it is 3 terms, so it's a trinomial. And we have two different situations. So after we determine it's a trinomial, we have to determine if x equals 1 or if x is not equal to 1. So let's take a look at that a little bit deeper. So if x equals 1, then there's not going to be anything here. That is 1. So for instance, here, there's nothing there. There's nothing there. So x equals 1 in this situation. When x does not equal 1, then we're going to see a number up front, and that number we call a. So for instance, a here is 2, and so how we factor it is going to be a little bit different based on that information. However, the first step and the way that I teach it is going to be the same for both of them. Now, there's a million different ways to teach factoring trinomials. This is just the way that I've used, and you're welcome to use any way you like, but if you get stuck, this is what I'm going to be showing you. So I'm going to use what I call the I-bar method, and I'm going to write it right under here because it's just a little organizer for you. But you first draw an I-bar for your trinomial. And on the top, you're going to put a times c. And on the bottom, you're going to put b. And here is where you're going to keep track of the factors that you come up with. So here are your factors. And these factors need to add or subtract to this. So we can just say add. Sometimes they're going to be negative. And they're going to need to multiply to this. Okay. Eventually, you're going to do it a bunch of times and you won't have to refer back to this. But when you're starting off, just go ahead and have this flowchart out along with these notes that you wrote down, and that'll help you memorize how to do this. Okay, so the reason I use this for both is because if you look at these notes here, I didn't create this, but it's telling you that you need to find factors of c, right? And here it says you're going to have to use a times c. Well, really, if a is 1, right, 1 here, and it's times c, that is still just c. So that way we're just memorizing kind of one way to start these problems. So let's go ahead and use the I-bar method here. And we're going to put in numbers here. So I need to do a times c. I'm going to use example number 1. So a is 1, c is -4. So 1 times negative 40 is -40. And then I need to put the b on the bottom. So my b value is 6. Now in the center here, it's just helping me keep track of what I've tried so far. Okay, if you feel comfortable with this and you're not feeling like you need the I-bar and you've got it down, great. If you ever get stuck, then I'm going to tell you to go ahead and do this. So what are the factors of 40? I'm not going to worry about the positive or negative right now, but 1 and 40 are factors of 40. Now, can I add or subtract these to 6? No. So those aren't the ones that I'm going to use. So let's just keep going. How about 2 and 20? Well, if I add it, that's going to be 22. If I subtract, that's going to be 18. So that does not get me to 6. 3 is not a factor of 40. So let's go ahead and try, how about 4 and 10? Okay, so if I add 4 and 10, I get 14. So, but what if I were to subtract 4 and 10? And subtraction just means that I'm adding and there's one of these is a negative. So that's going to work, right? Clearly, I need a negative in here someplace because a positive times a positive wouldn't give me this -40. So I need a negative in here. And so that this becomes subtraction. But which one needs to be negative? Well, since I'm going to get a positive 6, I need it to be 10 minus 4. So I'm going to go like this. Okay, these are our magic numbers. Once I have them, here's where it differs what you do when a equals 1 and when a does not equal 1. When a equals 1, you can just go ahead and set up your parentheses with your x in there. And you just put those magic numbers in there and you're done. When a doesn't equal 1, things are a little bit different, but not until you are through finding the magic numbers. So you start by finding the magic numbers the same way as we did above. So I'm going to draw my I-bar. I'm going to write kind of small here. And I'm going to use this example. So 2 times -20 is -40. And then my b value is -3. We already looked at some factors of 40 above, so I might not include everything in my chart, and that's totally fine. I'm already doing a little mental math going, okay, 1 and 40 are not going to add or subtract to -3. Neither are 2 and 20. How about 4 and 10? Well, we know that 4 and 10 subtract to 6 because we just did that. So what's the next one up? 5 and 8. Well, 5 and 8 can subtract to 3. So now I just need to decide where does that negative go so that way I get a -3. So I'm going to go with the negative on the 8. 5 minus 8 is -3. 5 times -8 is -40. So I have found my magic numbers. Okay, this is where it differs. I can't just plop those in. So now I'm going to have to see how to use that. And you're going to, I'm not going to rewrite it since we already have it here. But we're going to use them to split the middle term. And let's write that right here because you'll hear that a lot. Split middle term. Okay, make sure you have that on there. But what that's saying is we're taking our middle term of our trinomial and we're going to split it. But we can't just randomly split it. We had to split it into some specific numbers, and we use the I-bar method to find those numbers. That's how we did that. So I'm just going to take these. It doesn't matter which one you put first. In this case, they put the -8x first, but if you put the negative or the positive 5x first, that would be fine also. So the first thing you do is split the middle terms. Now, something that's not drawn on here, I always go ahead and put in the parentheses. And when you do that, important, keep this sign in your parentheses because when it's a negative, you're going to want to make sure you factor by a negative. Okay, so all we're doing now, and the steps are written here too, but we're going to replace the -3x with the -8x and 5x, and then we factor out the greatest common factor by grouping. Okay, so that's what I did here. I grouped these. So let's write that we are grouping because that's like one step down there for something that's really 3 steps. First we group, then I'm going to factor out the greatest common factor. So what is the greatest common factor between 2x squared and 8x? That would be 2x. So we're doing just like we did back here for greatest common factor. And we factor out the 2x right there. If I take 2x squared and divide it by 2x, I get x. And if I take -8x and divide it by 2x, I get -4. Okay, I'm going to do the same thing here. And it's important to have this, I like to put that sign inside the parentheses. So when I go to factor it out, I factor by whatever sign is on that. So since this is a positive, I'm going to factor out a +5. And then I'm going to figure out what is left in the parentheses, and that is x minus 4. Okay, and then actually you go ahead and factor again. Sometimes we don't think of it like that, but this, look, this is 2 terms. There's my first term, and there's my second term. And what do they have in common? Well, they have an x minus 4 in common. Okay, on this worksheet, they happen to have put that one second, but if I were to think of it like I'm going to take this and factor out an x minus 4, and take this and factor out an x minus 4, there it is right there. I'm factoring out the x minus 4 right there. And then to find out what this is, you just take this term, 2x times x minus 4, divide by x minus 4, and I get 2x. That's where this comes from. And then I take 5 times x minus 4 and divide by x minus 4. Those x minus 4s will cancel out, and I get this 5 right there. All right, so this is our fully factored form. Okay, we have one more situation here, and I don't think I actually have a practice problem like it on the page, but it's worth going over because when you have 4 terms, it is just like this one, but you don't have to bother splitting that middle term. It's already been split for you, is how you could think of it. We're going to start off by grouping. So put the parentheses around the first 2 terms and the last 2 terms, getting that sign in there. And now we're just going to look for that GCF in the first 2 terms. Well, I'm coming up with x squared, so there's that. And then I take all of this, divide out the x squared. I'm left with 3x plus 4. Do that again here. The GCF between 6x and 8 is 2, so that's where that 2 comes from. Divide it out, and you have 2 times 3x plus 4. Okay, again, if you think of this as just the common factor, then we have that. And when we divide out, we are left with this and this, which gives us that term, right? We're just going to put those together. Okay, so that was a quick review of how to do each of the factoring and how to use this flowchart. Now let's actually put this into action here. So number 1, we've already determined that we need to factor out the GCF. So go ahead, pause, factor out your GCF, and see what you have. Okay, this is what I came up with. So I need to determine if I can factor further. Well, what I'm looking at is what is in the parentheses. Is that a binomial, a trinomial, or a quadrinomial? That'll help me determine what to do next. So it is a binomial. And remember, all I really need to do here, right? There's three choices, but really only one of them means I have to actually do something. And that's when it's a difference of squares. So I need to look for perfect squares and see if there's a subtraction sign between them. So coming down here, I am just looking inside the parentheses. Well, this is a perfect square, and I do have a subtraction sign, but this is not a perfect square. So I'm done. This is my answer. Okay, scanning ahead here, I'm looking at 2 and 3, and those are both binomials. So why don't you go ahead and factor the GCF and then determine if it's a perfect square. And if it is, factor it. If you're unsure how to do that, just rewind and see what I did before, and then rejoin me when you're ready. Okay, for this first one, after I factored out the greatest common factor, there was nothing left to do here. Here, there was no greatest common factor, but it was a difference of squares, and so this is how it should be factored. Again, it doesn't matter which one's positive and which one's negative, as long as you have one of each. Okay, let's look at number 4 here. So the first step is to factor out a GCF. We've already determined that we can't do that on this one. So then, is it a binomial? So 2 terms, or 3 terms, or 4 terms? Well, I can see that's 3 terms. And then I want to determine, either way, I'm going to set up my I-bar, because that's how I like to do it. But then I want to determine, does A equals 1 or does A not equal 1? It's not going to change how I set up the I-bar. It is going to change what I do once I find these magic numbers. I start by setting up my I-bar. So A times C is 4 and B is also 4. And then I start to find factors. Well, their factors of 4 are 1 times 4 and 2 times 2. And it is the 2 times 2 that's going to work, right? Because it adds to 4 and it multiplies to positive 4. So what do I do next? Well, let's look. Okay, we have to do the I-bar, and then remember that we have to split the middle term, right? And then we're going to group, and then we're going to factor from that grouping. All right, so I'm going to split the middle term, which means 4x squared stays the same, but this turns into plus 2x, which I got from here, plus 1. Then I'm going to group, so I'll go like this. And then I need to find the greatest common factor in each of these groups. So for this first one, I'm coming up with 2x, which I then divide each of those terms, and I have 2x plus 1. Okay, for this next one, I'm not seeing anything other than 1 that goes into both of these, but I'm going to use that. Because this is positive, I'm going to make this positive here, and I'm going to factor out a 1, and now I have 2x plus 1. All right, one more step here is I need to factor out the GCF out of these two, right? And that GCF is this 2x plus 1. So I'm going to factor out 2x plus 1. When I divide each of those, I am left with this 2x and this plus 1. So we actually have 2x plus 1 again. You can write it like this, that's fine. You can also write it like this, either way. Turns out this was a perfect square trinomial, and there is another way to factor that, but I think we'll just stick to this way. And then at the end, if you end up with 2 factors of the same, you can just say they're being squared, right? Because that times that is just that squared. Okay, we're going to do one more just because it's a quick one here. So we start off with looking here if there is a GCF. There's not. So next place I'm going to go on my flow chart is it is 3 terms. Next, is it A equals 1 or A does not equal 1? Either way, I'm going to make the I-bar. In this case, it is A is 1. So when I'm done with that I-bar, I'm just going to plop those magic numbers right into the parentheses. So my I-bar, I have 1 times 3 is 3. On the bottom here, I have negative 4. The only factors I can think of are 1 and 3. So which one would have to be, they have to be added, but it needs to add to a negative. So they must both be negative in this case. Let's confirm this. -1 times -3 is a +3, and then -1 minus 3 is a -4. And since a equals 1, I can just go ahead and set this up. And I have -1 minus 3. Okay, the rest of these I'm going to let you try to figure out on your own. If you need to go back and rewatch anything, please do so, and I will see you in class.